On this page, we'll solve various equations involving logs by rewriting the logarithmic equations into exponential equations. We need to identify what's in the position of the base of the log. Once we've identified the base, you can rewrite the equation by letting the base be alone on a side and raise it to the power of the expression that's on the other side of the equals. So x to the 3 equals whatever the log is being taken of, that's what goes here. So to put it in general terms, what I did is this. I let the base of the log become the base of its own side. I let the y become the exponent of that base. And then the thing that we were taking a log of goes on its own side. That's how we write the exponential equation. Now we just want to try and solve that equation. So in this case, I will take the cubed root. That is how we would undo a cube. And the solution is x equals 2. Now in these types of problems, you should check your solution to make sure it really is a solution. Is it true that log base 2 of 8 is 3? It is true. It checks. All right, let's rewrite this one here. We need x minus 1 to become the base. We want to raise it to a power of 9, but we do have to make sure the whole thing gets raised to the power of 9, so put parentheses around that base. And set it equal to 81. Now we want to solve Now we'd like to solve by taking the inverse of a 9th power, which would be to take the 9th root of both sides. Now how do you take the 9th root of 81 on calculator? I mean, on the left side, they'll cancel off here. The 9th root and the power of 9 cancel off. So we get left with x minus 1 on that side. But how do we take a 9th root on a calculator? You could type in 9 n root button, and it would look like that on your TI-30X2S calculator. How did I get that? I pressed 9, then second, then the caret button, which is also the n root button. There's a little x in the square root symbol. And then type 81. I get x minus 1 is approximately equal to 1.629. Finally, we'll just add 1, getting 2.629 approximately. As with any solution, we should check it just to be sure that it really is a solution. Is it true that 1.629 to the 9 is 81? Check it on calculator. It does check. All right, one more example here. Let's rewrite it into exponential form. 2 to the 4 equals x plus 1. 2 to the 4 is 16. It looks like x is 15. We'll check it. Log 2 of 15 plus 1 equals 4. Is it true that log 2 of 16 is 4? It is true.